Hello, pre-algebra students. We're getting ready to take a look today about linear relations and how to graph them. Actually, today we're only going to do half of the lesson. Today we're going to look at the linear relations or the linear equations and kind of find out how to find some solutions to them. And once we've figured that out and unraveled that out, that'll be plenty for you to get your mind around for today. And we'll be taking a look at how that translates into graphs on Monday. Well, what does that mean for tomorrow then? What that means for tomorrow is I want you to do a checkup just to see how you're doing. I want it to be stress-free. I want it to be an honest thing, your part, so that I can see how you are doing. So it'll be set up as a quiz link that you will go on. You will take the quiz, but it will not count for a grade. I can't reiterate this enough. It will not count for a grade, but I need to see what you're understanding and what you're not understanding, so I do need you to do your best. It will count as an assignment, which means that you can get 100 on an assignment, but I'm not taking points off for the ones that you get wrong. I just want you to do your best. Show me what you know. Okay, so that being said, you know I love you, and so I'm trying to do my best and get you to where you need to be. This lesson is super important. Graphing linear relations. Linear means a line, and we will get to that more tomorrow, but the first thing you need to be able to do is you need to be able to evaluate whether a certain ordered pair is actually a solution to a given equation. Now, in order to tell that, what you need to do is you need to find out if this x and this y go together to make this true or not. Now, what I want you to realize here also is that there can and will be millions of ordered pairs that would actually make this work. Right now I have 4 examples, and we need to check each one to see which ones are solutions. So once you found an answer that works, don't say, okay, I found it. It's not a matter of finding it, it's a matter of finding them. There could be more. As a matter of fact, there probably will be. So the first thing I want to do is I want to see if 3, 5 is a solution. In order to see if 3, 5 is a solution, this is your x value and this is your y value. I'm trying to see if I plug 3 in where x is, if that's going to give me the answer, does that equal 5? Here's your x and here's your y. So 5 minus 6 gives you -1. That's not 5. So this one's a no. This is not a solution. Let's take a look at 1, 3. Finding out if this is a solution. X here, y here, because every ordered pair has an x and a y. So I'm checking to see, does 5 minus 2 times 1, does that equal 3? Well, let's see. 5 minus 2, hey, that does equal 3. So yes, this one's a solution. Yay, this one's a solution. I want to check another one. Let's check -2, 4. So I need to find out from the equation if 5 minus 2 times 2, does that give me 4? Ah, wait, but I made a mistake. It should be 5 minus 2 times -2. Because here's your x and here is your y. So do be careful with the signs because they do matter. Do what I just did and Take a second to look over just one last time to make sure that you've pulled everything down from the original, just to make sure. So 5 plus 4, that's 9. 9 does not equal 4, so it's a no. This one's no. So we have just one more to check. So I want to check this -3, 11. 5 minus 2 times -3. We're finding out, does that equal 11? 5 plus 6, because minus negative makes plus. Hey, it equals 11, so that means yes, -3, 11 is a solution. So the two solutions out of this list that make it true are 1, 3, that's one solution, and then the other solution is -3, 11, and I just showed you why. It's very, very important to note that the solutions are the ones that make this true. The ones that don't work out, they're not solutions of this equation. Why is that important? That's important because this equation is really giving you information so that you can find millions of ordered pairs that actually make this true. Now this one, but what you can do actually an x value and a y value. We have to give solutions to an equation ordered pair as an x value and a y value that make this. So what we need to do is we need to find a process to find some of these numbers. I say some of these numbers. I said there are millions of them. I'm never going to want you to find millions of them. What we're going to do is we're going to find 4. If we can find 4 solutions, that's going to be helpful for us for making what we'll call a graph. And we will get to that part tomorrow. But for now, let's work to find 4 solutions to this equation. So how do we do that? All right, well, how we do that is we're going to set up a chart. Okay. We're going to do x values. I'm going to make another section of the chart with what we're trying to find. 2x minus 3, so I can keep track of what's happening. And then finally the y value. So here's the part that gets interesting, because if there are 13 of you in the class and you each pick 4 different numbers, you might pick 4 different ordered pairs and all be right. Okay? You can choose whatever x values you want, and then you're going to do a little calculation to find out what y value goes with it. So the numbers that we pick for x are your choice. Okay? You choose the x's. Now what I would suggest is that you choose small numbers that are easy to work with. Choose small numbers that are easy to work with. You can choose positive numbers, you can choose negative numbers. It is your choice. You choose the numbers. So if somebody asks, gee, what numbers do I have to pick? You don't have to pick anything. You choose the numbers. Now, like I said, pick small numbers to make it easier for yourself. Like for example, I want to pick the number 0. I usually like to pick the number 0, quite honestly, because when I plug 0 in for x, this is easy to do. 2 times 0 is 0. So I have 2 times 0 minus 3. So that gives me 0 minus 3, which gives me a y value of negative 3. You can pick another one, okay? You can go in order or you don't have to. I'm going to pick a 1 here. 2 times 1 minus 3. I'm always using this same pattern. You're just putting in the x values. So 2 times 1 minus 3 gives me 2 minus 3. And 2 minus 3 gives you negative 1. There's value number 2. Value number 3. I'm going to keep going because this looks like it's coming along pretty well. If you want to, you can always pick 0, 1, 2, 3. That's fine. But when you start to do more and more of these, you'll see that sometimes some numbers are, how do I put this, more annoying to pick than other numbers. So you're going to get wiser and wiser on your choices as we go through. And so there's a solution to that one. And we can go through and pick another number. 2 times 3. Notice this part stays the same and this part stays the same. It's only the number that you picked that gets changed. So I need to find 2 times 3 minus 3. 6 minus 3 equals 3. Now it does say in here that the final part, write the solutions as a list of ordered pairs. Now when we do the list of ordered pairs, you're going to want to make them look the best, you would want to put them into set form, into set notation. We're not to the point where I'm going to require that just yet. So we're just going to make of these ordered pairs for you. So an ordered pair has a has an x value and a y value. So in this case, 0, negative 3 is one of my ordered pairs. And hopefully you're seeing, oh, okay, now I see where the graphing is going to come in, but we'll do that tomorrow. 1, negative 1 is one of my ordered pairs. 1, negative 1. 2, 1 is another one of my ordered pairs. And 3, 3 is another one of my ordered pairs. So what happens is you end up with a list of these numbers, and you can imagine, because I told you you could pick whatever numbers you wanted, you could go on and on and on and on and have a giant list of numbers. I could put in 4, I could put in 5, I could put in negative 85 and still plug in the number and get a new answer. No matter what x value I choose, I'm going to be able to find another y to go with it, and another y to go with it, and another y to go with it. So this is why I'm saying I'm only going to make you find 4 solutions, and we're going to graph them, but our graph is going to represent all of those millions of solutions. So we're going to keep that in mind, but let's practice another one, finding solutions to the equation. So what I want to do with this one, I have y equals 1.2x plus 1. When you make the chart, if you consistently always put the x first, that's going to be helpful. I'm going to put another thing in here. And here's my y. And so 1.2x plus 1, so I can follow my pattern as I go through. Now, just because I want to show you that you don't always have to pick the same numbers, I'm going to start this one with how about negative 2? 1.2 times negative 2 plus 1. So I'm going to do this math over here on the side. 1.2 times negative 2 plus 1 equals negative 2.4 plus 1. So negative plus positive means I subtract. Let's review our decimals a little bit. This 1 is in the ones place, so you'd have to do that. My answer is negative 1.4. Okay, let's pick another number. I'm going to pick 0. I do not even have to go in order. All I have to do is have 4 numbers. I like 0. I am always going to be picking 0 as one of my numbers. 1.2 times 0 plus 1. Super useful number that 0 is, because it makes the easiest problem. 1.2 times 0 is 0. 0 plus 1 is 1. That one's done. Then how about I pick a 1? Let's do a 1. 1.2 times 1 plus 1. 1.2 plus 1 is 2.2. And I forgot to put this in my chart. 1.2 times 1 plus 1. Okay, notice I'm really just putting it in the chart so that you're remembering that it's always the same problem. Sometimes people will accidentally change numbers that are not the variable. It's only the variable one that is getting plugged in for with whatever number that you want. I'm going to pick 5 here just to kind of be a little bit of a renegade. 1.2 times 5 plus 1. And you can pick whatever numbers you want. There are millions of correct answers. 1.2 times 5, well, let's see, 1.2 times 5, 10, 6, is it 6, plus 1 is 7. Okay, so I have 4 x values and 4 y values that go with them. You want to make your answer into a list of ordered pairs. So I have negative 2, negative 1.4. I have 0 and 1. And I have 1 and 2.2. And I have 5 and 7. So we have our list of ordered pairs. This is our answer, the solutions that we found from that. And this one is interesting. It's got some decimals in it, but it also came out for some whole numbers. And I want you to think for a minute. I know we're not actually drawing graphs today, but I want you to think for a minute which ones of these would be easier to graph. Okay? And when you think about which ones would be easier to graph, you could easily plot the ordered pair 0, 1. You could easily plot the ordered pair 5, 7. These with the decimals would be a little harder. So when I say you start to get the idea of what numbers are going to make things a little bit easier, if you can get more whole numbers rather than decimals, your work is going to be easier for graphing. We could still graph these, and that will be fine. But I'm just trying to give you a little picture forward. For now, you're plugging in the values, you're getting answers, and even if your answers look different than another person in the class, if you were to all get together and you were to compare answers, you might find these different. So when you're checking the solutions in the back of the book, okay, it will probably say something like answers vary. The reason is my list of ordered pairs might look different than your list of ordered pairs if you picked different numbers for x. Okay? However, if you pick a 0, your answer for that ordered pair would have to be exactly the same as my answer for that ordered pair, because we would have done the same math in order to find the answer. Same thing if you pick a 5 and I pick a 5, we both have to get 7 when we've plugged it in correctly. But you might have decided that you wanted to pick a 3 and you plugged it in and you got your answer, and 3 and whatever you got would be another perfectly good solution for this problem. So your answer might look different than my answer, but if we pick the same x's, we have to have gotten the same y's. All right? I am really taking my time on this lesson because I know from all my experience that if we don't get this part, then we're going to have trouble for the next few years. Okay, that's how important this particular lesson is. All right, so I want to make a chart of x values and y values. But in this case, I'm going to put my x and my y next to each other, because if you'll notice, x and y are on the same side, and it's easier to kind of put this like this, so when you're thinking it through, x plus y has to equal 4. So no matter what, x plus y equals 4. So when I start picking my x values for this, okay, let's say I picked a 0. I'm looking for what number goes with 0. 0 plus what number equals 4. And some of this part is just mental math, because 0 plus 4 equals 4. So y equals 4. Over here, I'm putting in a 1. So I'm looking for 1 plus what number equals 4. So 1 plus what number obviously is 3. Now I'm looking for 2 plus what number equals 4. I take away 2 from both sides, so y equals 2. Okay, so it would be too easy for me to just go to 3, because 3 plus 1 equals 4. That works. That's great. I'm going to pick another one just because I want to show you what can happen. I'm saying, well, 5 plus what number equals 4, because it all has to equal 4. Well, in this case, my what number question is a little harder. And I'm showing you this one because the problem that you have to work through in the book might have something like this. So y would equal -1, and then check it back out. 5 plus -1 equals 4. Okay, and so you could have your list of ordered pairs. You could have 0, 4. You have 1 goes with 3. You're always putting the x's and the y's in your list of ordered pairs. You have 2 goes with 2. And we have 5 goes with -1. All right, so that is enough for you to chew on for today. I chose problems for you to do today that are all kind of like this, so that when you're done doing today's practice, that it is all going to 100% make sense to you. All right, the way that I have it worked is that since yesterday was a Wednesday and I'm trying to keep things consistent for you, the homework about the scatter plots is not due till tomorrow. Tomorrow you will do the practice quiz rather than see a new lesson. And the homework that goes with this one is going to be due on Monday. Assignment 74 is due on Monday. And by then I'll have had a chance to look at your quizzes that you'll submit tomorrow that's part of your classwork grade, but only as a safe way to practice. And then we will be able to go forward from there, and I'll be able to teach Monday's lesson with the things that you're having difficulty with in my mind. Okay? All right. I hope that you have learned a lot today, a lot for you to chew on. And please know that I'm continuing to pray for you. Praying, I got a couple prayer requests from somebody in here. So I prayed this morning for somebody's grandma. I know this is going out public, and I did pray also for somebody to not have anxiety, and just somebody to get closer to God also, as that was asked. So, all right, I will hopefully see you fairly soon, and God bless.